Good afternoon. My name is Cutler Cleveland. I'm a professor in the Department of Earth and Environment at Boston University, where I am also the Associate Director at the Institute for Sustainable Energy and a faculty affiliate for the Center for Anti-Racist Research. In 2019, the Institute for Sustainable Energy published a suite of reports for the Boston Green Ribbon Commission and for the City of Boston that described and quantified options available to the city to reach carbon neutrality by 2050. That work included a social equity report that assessed how the city can decarbonize in a manner that improves life opportunities for all residents, including socially vulnerable populations across the city. We propose to build on this work by designing and deploying a screening tool and other data products for environmental, energy, and climate justice in the city that are grounded in the best practices of data science, data justice, and community engagement. My brief talk is intended to be a starting point for discussion regarding the vision for this work and for its details. Environmental data justice lies at the nexus of four interconnected spheres of justice. Environmental justice is a principle that people and communities have the right to equal environmental protection under the law, the right to live, work, and play in communities that are safe, healthy, and free of life-threatening conditions, and equitable access to environmental benefits. Climate justice is the principle that the costs and benefits from the mitigation of climate change and the adaptation to impacts of climate change are equitably distributed, and that people and communities are equitably engaged in climate change decision making. Energy justice is the principle that every person should have reliable, safe, and affordable access to essential clean energy services, such as thermal comfort, illumination, and mobility, that the benefits and costs of energy systems are equitably distributed, and again, that all people have equitable access to the energy decision-making process. The datafication of society makes data justice an important element of justice. The collection and analysis of massive data sets from our personal and social lives is increasingly normalized. Examples include the Internet of Things, smart home and smart cities, the platformization of digital media, and the governmental and corporate uses of citizen data. From datafication springs new power dynamics that demand scrutiny. As defined by the Environmental Data and Governance Initiative, environmental data justice refers to public accessibility and continuity of environmental data and research, supported by networked open source data infrastructure that can be modified, adapted, and supported by local communities. Environmental data justice is motivated by the reality that most data and algorithms are generated by hierarchical structures in industry, government, and science. Data are always embedded in the politics of its generation, collection, and interpretation. As a result, data systems can perpetuate social norms and status quo that often share roots in oppression and exclusion. Like all data, energy, climate, and environmental data can be weaponized via victimization, surveillance, financial scoring, and technological redlining. Environmental data justice thus includes maintaining attention to a long-standing environmental justice concern about what might be called the politics of evidence. That is, what and whose knowledge and data are counted as valid and whose interests are served by data. Control of these decisions is an exercise of power that must be critically examined. Environmental justice now has a voice in Washington. In the first days of his term, President Biden signed an executive order that described broad federal action on climate and environmental justice. Representative Raul Grijalva co-sponsored a bill in the House that is known as the Environmental Justice for All Act. I highlighted portions of those acts that illustrate the importance of data access and analysis to simultaneously improve equity on social and environmental fronts. Despite the importance of and growing interest in data surrounding sustainability, there are surprisingly few rigorous and accessible tools. We have reviewed most of them, and here's a high-level summary of current best practices. Most existing environmental justice screening tools rely on a common set of data. Many include certain land classes that are included in a geospatial database, such as childcare facilities, healthcare facilities, parks and playgrounds. Most include geospatial data on pollution burden, which has two components. The first are what are called environmental effects, which includes the location and nature of potential hazards, such as hazardous waste sites, cleanup sites, and groundwater threats. Those effects are then translated into potential exposures to things such as particulate matter, drinking water, contaminants, and toxic releases. Most environmental justice screens also include a suite of population characteristics, including certain vulnerable populations related to health, and a lot of socioeconomic factors, such as level of education, linguistic isolation, race and ethnicity, and poverty. Many of the state EJ screens also include some base GIS data, such as parcel databases, zoning maps, topography, land cover, and other commonly collected data. Here's an example of the type of data that are included in most screens, which relate directly to the types of hazards and facilities that the federal EPA regulates. These include air toxics, particulate matter, and other air pollutants in proximity to sites that pose some type of hazard or risk to the environment or to people's health. Let's go online and look at a couple of existing commonly used screening tools. I'm at the site of EJ Screen, which is the federal EPA environmental justice and mapping tool. And I'm going to go down and type in the zip code of my office at BU in Boston. And this launches the tool. You can see the city of Boston. Let me scroll out a little bit here so we include our neighbors in the southern neighborhoods of the city down in Hyde Park. So this is a product produced by Esri, which is a well-known company that produces GIS tools. And it comes prepackaged with a lot of data and tools. For example, you can change the base map to be either topographic or streets or imagery and so on. So I'm going to go over here and add maps, and I'm going to click on sites reporting to EPA. And this is going to load some sites that the EPA collects data on. You can see these are Superfund sites. I'm going to click in the upper right here in the legend on brownfield sites. So it adds brownfields to the map. I can also click on air pollution, and this is going to add locations, and each one of these has data associated with it. The air pollution sites are facilities that have been issued some type of permit by the EPA to release a type of air pollutant. I'm going to unclick the air pollution and note that you can zoom in here and get some very detailed information if you're interested on where these are located. So these are brownfield sites. And there's some other tools that are included in this Esri tool. For example, I can measure distances. So let's say I lived in Roxbury here, somewhere on St. James Street, and I wanted to know how close I was to the nearest brownfield. So I could draw a little line here, and it would tell me that I'm 0.3 of a mile from that particular brownfield. I'm now going to move over to, so that's a federal EPA screen that includes those types of data that the EPA collects and regulates. I'm now going to move over to one of the very few city level screening tools. And this is one built by the Center for Earth, Energy, and Democracy for Minneapolis and St. Paul. It's also the same ESRI tool, so it has these different base maps, for example. And if I look at the additional information they include, for example, they have local political boundaries, parks and open space, they include food stores and so on. So if I choose contaminated sites, it's going to show me, zoom in here a little bit, show me where various types of contaminated sites are located. And these are sites that might have a spill that has been reported or is somehow regulated by the state or federal EPA. I can then go up and layer on top of this, so some socioeconomic data. So I'm going to choose income as a percent of the average median household income for the country. And you can see these data are available at the census tract level. And the darker colors represent areas that have lower household incomes measured as a percentage of the average American household income, median income. And again, you could start to begin to use this tool to look at the relationship of certain environmental hazards to this type of socioeconomic data. The city of Boston has set lofty goals for adaptation to climate change, carbon neutrality, open space, waste management, and social equity. We propose to support those efforts through the design, development, and dissemination of state-of-the-art data science tools. This process will advance justice in the city through meaningful participation in other best practices of environmental data justice. We propose a series of interconnected initiatives. The first is to harness big data in ways that has not been done before in these types of screening tools. Expand the scope and type of impacts and exposures, especially those related to equity. Fully engage the community in the design of the data collection and use of visualization and other types of tools. Support citizen science, including the ability to ingest and display and analyze data supported by this type of participatory science. Expand data products beyond the simple exposition of maps, which are great, but we can go well beyond that. So let's look at each of these initiatives in a bit more detail. The first column lists the various types of what have become now known as big data: harvesting social media, crowdsourced data, open access data initiatives, and so on. And these can be extracted with various types of tools that are now possible due to advances in computing and data science. There are also existing databases that have not been utilized heretofore and tools that also exist that can be used in a comprehensive screening tool. For example, the EPA has information on the history of all its enforcement and compliance, which could be extracted and coded in a geospatial way and mapped to these other types of information that you've seen. They also have a tool called eManifest, which tracks the precise movement of regulated materials, particularly hazardous and toxic waste, which could be extracted to let and be presented to people in a way that could let them discover what types of materials are being moved through or around their communities. There's a growing and large amount of data related to energy, climate, and sustainability that could and should be extracted and used in this type of screening tool. First and foremost are the large amounts of data related to exposure to water through flooding and sea level rise and heat exposure due to climate change. I'll come back and speak in a moment about what Boston has already done in that regard. Issues related to food security. Now I have a lot of spatially explicit data. There's a lot of important information about urban ecosystems and open space that go beyond simply mapping the location of open space. Urban ecosystems provide a large array of ecosystem services, such as reducing stormwater runoff and sequestering carbon that could be quantified and used. Reducing greenhouse gas emissions to meet carbon neutrality goals requires building new net zero buildings and retrofitting old buildings to become more energy efficient. That involves a lot of information about energy efficiency, indoor air quality, and the connection to human well-being. A lot of information related to traffic disamenities, the negative impacts of traffic in its many facets, can be assessed in a more rigorous way. Decarbonization requires access to rooftop solar and heat pumps and new electric boilers running on clean electricity. And transportation will also need to be transformed to meet equity and climate resiliency and climate mitigation goals, including access to more active transport, biking and walking, and emerging options such as ride hailing and perhaps autonomous vehicles. And then there's a lot of information already at hand for the city of Boston that could be utilized. 311, for example, contains a lot of information about people who call the city to request information or complain about or report on a variety of issues from potholes to snow removal to bike lanes and other topics which relate directly to issues of justice, sustainability, climate, and energy. Analyze Boston has a couple hundred geospatial data sets that in some way touch upon these issues. These could and should be extracted and put in such a screening tool for the city of Boston. Here's an example of some of the excellent data already made available by the city and its collaborators that could be integrated into the type of screening tool and data products that I'm describing. This is the Climate Ready Boston Map Explorer, which maps the potential impacts of climate change on the city's people and infrastructure. And this also is the same ESRI tool that we've been looking at. So I can plot or display what the 1% chance of annual coastal flood in the 2070s. This is based on projections made by climate models on what will happen to sea level rise and flooding. You can see the increase in areas that have a 1% chance of being flooded in this scenario. I can also, for example, look at impacts associated with long-term flooding. You can see more affected areas there. And then I can map certain demographic variables such as communities of color, where they live in the city, and you can begin to see visually and extract data that describes the potential impact of these climate impacts on socially vulnerable populations. This entire database, perhaps in updated form, is essential to a comprehensive environmental justice screening tool for Boston, and it is an example of the type of data that we propose to pull into this new tool. In response to almost any prompt, experts are always or frequently quick to say, well, we just need more data. While true, that's a very incomplete response to the type of challenges that the city faces. in regards to energy, climate, sustainability, and equity. So one of our central organizing principles is to organize this work from start to finish around meaningful community participation. Community participation will produce social and scientific outcomes, much better outcomes compared to singular reliance on experts. So we want to avoid helicopter science in which experts swoop in, collect data, swoop back out, analyze data, publish results, all with little engagement of local residents. Effective and equitable work embraces community-based participatory research and community science projects. This requires moving to the right on the spectrum shown here, which is a continuum of community engagement, and moving to the right end of the spectrum that includes collaboration and ultimately deference to local communities for the design, construction, and maintenance of these types of databases and how they are used. We also want to support citizen science, and this is directly related to the community participation initiative. Citizen science is the voluntary involvement of the public in scientific research, including social science. Citizen scientists can help solve real problems and answer real questions. And citizen science builds trust in impacted communities and increases scientific literacy. The availability of reduced cost of portable or personal environmental monitoring technologies, increased access to Wi-Fi, and user-friendly visualization tools are key drivers behind the increased interest in participatory research. The robust data system we propose has the capacity to support the types of information generated by citizen scientists. And you see some examples here of types of citizen science and research and data collection that has happened or could happen. A lot of it historically has been in this area of monitoring air, water, and soil quality, which is where these new advances in the cost and ease of use of portable or monitoring technologies. But there's lots of other information that creatively done could add a lot of information to this type of screening tool. For example, in the case of transportation, reducing emissions and improving equity and quality of life, we need more and better sidewalks and bike lanes, which are very amenable to monitoring. Issues related to stormwater runoff are important and could be monitored. An interesting example that I came up with the city of Providence is in the area of historical narratives, where they went around to different parts of the city and had individuals either interviewed or had them write oral histories about the development of buildings and commerce and housing in their particular area, and then build a geospatial database where you could click on these different neighborhoods and learn about how people describe the history of development in those areas. Very interesting and powerful stuff. We propose to expand data products beyond the display of maps. These include the generation of reports by subject or region, a diverse set of visualization tools, the capacity to aggregate data into indices, and the capacity to download data sets for use in multiple applications. Data products must support a wide spectrum of users, including expert researchers, decision makers, government agencies, high school and college students, and community organizations and other NGOs. The data products must be designed to account for differences in people's access to broadband and computers, level of educational attainment, language, income, and other socioeconomic factors. So that's a quick overview of the idea that we have, and I'll simply close and launch a discussion by observing that environmental data justice, in our view, is an opportunity to advance overall justice in Boston and to accelerate progress towards the city's clean energy, climate, and other sustainability goals. And I look forward to exploring this opportunity with all of you. I'll close here with my contact information. Should anyone want to reach me, you can catch me there by email or on Twitter. And I look forward to talking to you.